Algebra 1, 8.7 is where we are. If you have the vocabulary paper, we filled in a little bit yesterday. We can fill in 2 more, 7 and 8 today. So there's 2 options today. We're dividing polynomials today. So one choice today is dividing by a monomial. How we do that is divide into each term. So I have in mind a problem like this, where there's no adding or subtracting after the division sign. These first 2 we're going to be dividing by a monomial, and we're going to want to just divide into each of those terms. Second choice we have is to divide by a polynomial. This question and the ones to my right, after the divide symbol, there's some adding or subtracting going on to create a polynomial. For those, we're going to long divide. So again, 7 and 8, the 2 choices are to divide by a monomial, divide into each term. Second choice, divide by a polynomial, we're going to long divide. So here's how this looks in the real world. They're going to give you one group in parentheses to start you, and have you divide by a monomial. This is basically distributing backwards. Okay? If I didn't do the divide and it was just multiplying, you would distribute through. When you multiply, the powers add. Today, we're dividing into each of these, and the powers would like to subtract. So if we divide this by this, there's an invisible 1 if that helps anybody. 4 divided by 1 is 4. X cubed dividing x squared, we'd subtract those powers, we'd get an x to the first, or just an x, we don't have to write that 1. If we divide this one, 2 divided by 1 is 2. X squared divided by x squared, that's a complete cancellation there. When we do 3 divided by x squared, we can't really do that because there's not like variables on both of those. What we might want to do is just put 3 on top of an x squared as our answer, probably is our best alternative. Possibly a different way to write this that you might prefer. You don't have to do the parentheses like that. Instead of dividing x squared, you might want to put the whole thing on top of an x squared. It's the same answer, but it just looks a little different. Sometimes people prefer to look at it this way. Again, divide the 4 and the 1 to get a 4. Subtract these powers to get a 1. Divide these to get a 2. Total cancellation of these leaves no x's. 3 is already on top of x squared when you look at it that way. Sometimes people like that better. This problem, same thing. Okay, so 36 dividing 6 is a 6. x4 dividing x3 leaves you an x because we subtract powers, and there's 1 left. 18 dividing 6 is 3. X cubed dividing x cubed is a total cancellation, so we don't need anything to do with that. If we do this dividing this, it doesn't quite divide evenly, so maybe we want to make a fraction there. Put the 9x squared on top of a 6x cubed, and just do a little bit of canceling there. 3 goes into both of these to leave 3 and 2. And then when we look to eliminate x's, there's 1 more x on the bottom, so it could look like that. And again, if you don't like looking at everything straight across like that, do a fraction mark, put 6x cubed underneath it, and just try to divide into each. Okay? But if we have a monomial here, we're just going to divide into each thing. If you have a polynomial, then we're going to long divide. Long division, you may remember that the second number goes outside and the first number goes inside. Like if I wanted to say 846 divided by 21. You put 21 out, you put 846 in. When you go to divide in the old-fashioned way, you just look at the leaders. You wouldn't really think about 21 times tables. You would just try to take 2 into 8. 2 into 8 goes 4 times. That would get you started. This works similarly. You only look at the leaders at the beginning of each item. A squared starts the dividend. A starts the divisor. If you do a squared divided by a, That would be an A. Just like on this, we were thinking about a 4. And now the process is going to be the same. In this world, you would take 4 times all of that and get 84. In this world, you take A times all of that. A times A is A squared. A times 1 is A, still a plus. In this world, you'd subtract, and you would drop the 6. In this world, we're going to subtract, which eliminates these. Subtract gets us 3A, and then we would drop the 5. Then we go again. And I think I meant for this problem. No, okay, I'm good. Now we'll divide again. We would take this into this. Just looking at the leaders. First of this is 3A. First of this is A. If you divide these leaders, the A's would eliminate, and you get a 3. Anything you write up top in the quotient has to multiply everything. 3 times everything is 3A plus 3. Once you do that, we'll subtract. Those will always eliminate at the beginning of the line. Subtracting here gets us 2. Some algebra books will let you put a remainder and a 2. Our algebra book wants us to tack on a fraction. Like this fraction would have been 6 on top of 21. Our fraction is going to be a 2 on top of an A plus 1. We'll do 2 more of those. So this one, I'm going to go 2x squared plus 4x plus 7 in the box. The first item goes in the box as the dividend. X plus 3 goes out of the box as the divide circle. And then we're going to divide, always focusing on the leaders. If 2x squared divides x, that's going to get me a 2 and an x. Because 2 divides 1 to get 2, x squared divides x to make x. If that didn't make sense, think of it this way. If 2x squared is dividing x, put 2x squared over x. A little bit of canceling, and it should arrive you at a 2x. Once you have a piece of the quotient, it has to multiply everything out here. 2x times this is 2x squared. 2x times this is a plus 6x. This multiplies everything to make a new line. Then it's time to subtract. At the subtracting phase, the beginning of the line will always eliminate. 4 subtracting 6 is negative 2x. And we're going to just drop the top level. And then go again. We'll divide the leaders again. If we divide these, it should get negative 2. Because the x's would eliminate. If you don't understand that, take a side trick. I'm taking this first item divided by that first item. X's cancel. That's where the negative 2 came from. Anything from the quotient, its job is multiply everything. So negative 2 times both of those is negative 2x minus 6. Once we create that second line, it's time to subtract. These will always eliminate because they'll always match because we forced that. Here we have 7 subtracting negative 6. There's a 7, there's a negative 6 we can see, but in our mind what we're thinking about is subtracting all of that stuff. We have a little minus minus makes plus there to get 13. And that's going to be a remainder. Best way to write the remainder for our book's style is make a fraction, 13 on top, the original divisor to the bottom. One more, same game. This is going to go out front, 2b minus 1. This is going to go inside, but I'm going to do a little different thing here because they didn't do all of the powers of b. This had an x squared and then an x and then nothing. This has a b cubed. They skipped a b squared possibility, went on to the b's, skipped the number alone possibility. So in a question like that, I would suggest leaving gaps. Go 4b cubed, leave a gap for where b squareds might have been before you do the plus 7b, and leave a gap for where a number might eventually go because we might need those spaces. always just look to divide the leaders. If you have trouble following that, take a side trip where you take the first thing on top of the other first thing, do a little canceling, and this would get me 2b squared. Anytime you get a thing in the quotient, it multiplies everything in the divisor. So this times this is a 4b cubed. If that is not a perfect match, you messed up. This times 1 is a negative 2b squared, and I'll keep that lined up with the gap, because this is going to be where all the b squareds go. All the b's in this column, all the numbers in the other column, so I'm glad I left that gap. When I go to subtract, those always vanish at the beginning of the row. And if I'm subtracting a negative, again, I have a little minus minus makes plus for this one. But the top row never changes, it just drops. And now again, we look to divide only the firsts. The 2b squared from this, dividing a 2b from the divisor. Cancel 2's, cancel most of the b's, that's going to get me a positive b. It's positive divided by positive, so it's positive. I leave a plus in that circumstance. Anything from the quotient has to multiply the whole world out here. So that's a 2b squared minus a b when we multiply those. Now it's time to subtract. As always, perfect match to eliminate. With a negative here, we continue to think minus a minus makes us add. So I'm going to get up to 8b and go one more time. If 8b divides 2b, grabbing this and that from the beginning of each piece of the world, b's are gone. 8 divided by 2 is a positive 4. 4's job is to multiply everything to get 8b minus 4. Subtracting makes those vanish, and as it has happened a few times, we're subtracting this stuff, so minus minus makes a plus. The remainder is always a fraction. Put the 4 we just got on top, and the bottom of that remainder fraction is always copying the original divisor. And that is where we are. Homework on this is a page 344 from 1 to 24. If you have questions, email me.